These machines were complex enough that you could use them as the way we use machines now. I had word processors, desktop publishers, and used them for all sorts of things. But they were still simple enough that one person could understand not just the software and how to write programs, but actually how the hardware would work as well. One thing you may have noticed at the screen is we have these huge borders around the edge of the screen. And the way the hardware is designed is that you've got these borders. Suspect these are probably there because your televisions at the time would what was called overscan, so that some of the image would be hidden behind the edges of the screen. So you'd leave the borders so you could see everything on the screen. But it meant that you only had this small section that you could actually draw into. That was until the programmers came along. So I'm changing the software again. So this is not mine, this is something from a group in Luxembourg. And what we've got here is what was called the demo scene. So the demo scene was young teenagers, early 20s type people, and perhaps older. I wasn't really involved with it much, who would write this software and would then share it among their friends. Not on the internet as we do now, because at this point that was still limited to academics, really, but actually through things called bulletin boards, where you dial up your modem on your computer to another one and copy the software off, or even just sharing floppy disks in the playground. So I'll turn the sound down. Now if you look, we've got graphics all over the screen, and I said, well, the machine was designed to only display it in the border. What's going on here? Well, lots of people, when they started to program this thing, people began to realise that by understanding how the hardware worked, and they knew how their software worked, that they could trick the hardware into drawing graphics in the border. And it's actually quite a clever thing, because it relies on the fact that when you design hardware, you want to do the simplest hardware implementation as possible so that you don't have to use any more transistors in the silicon than you have to. So on old CRTs, you draw each line separately, one after the other across the screen. So on a PAL screen, you've got 625 lines in an image, but because of the way video systems work, you get two what are called fields of about 312 lines each. So as far as the Atari is concerned, each image that it shows is 50 of them a second, is 312 lines high. The hardware inside is counting each of those lines. Every time it starts a new line, the hardware is counting. It says in the hardware, I'm at line, whatever it is, start showing the display. And then it comes down to, I'm at line 200 and something, stop showing the display. What people realise, that this is slightly different for the American system. These machines could work both in the UK and the US, and anywhere else in the world. If they switched it from being a UK machine to a US machine at just the right point, in terms of the video frequencies, the hardware would say, well, I'm a UK machine, so I don't have to do anything here. Then a bit later on it would say, I'm a US machine, I don't need to stop the display here. And it would carry on displaying graphics into the border. So by some very, very clever programming, switching things on and off, literally counting exactly how long each instruction the CPU takes, so that things can be turned on and off in the hardware at exactly the right point, they were able to get graphics into the whole display there. And so it was really nice for a programmer that you could understand everything that was going on and program it.
So they hacked it?
To an extent, yeah, they hacked it. Well, not so much hacked it, they pushed it beyond what the designers had intended it to do. They understood what the designers had done and then changed it. And you saw this with other computers. People did it with the Commodore 64 as well, and other things. The programmers pushed the machines further than people expected. It's easy to do these sort of graphical effects for a demo like this, but it's much harder to do things like full screen in the middle of a game, and so often the games would still have smaller displays and so on. And in fact, one of the slight issues with the original design of the machine before the enhanced one is that the CPU didn't quite have enough time to be able to smoothly scroll the screen like you would see on perhaps on something like the Commodore 64 or the Amiga, which was also popular at the time. And so people had to perhaps reduce the size of the screen slightly or come up with clever programming tricks again to be able to do something like that. So it was really a machine that the programmers enjoyed because they had to think clever to work out how to program things. There was several versions of the Atari ST created. The early ones are pretty much the same hardware, just in different configurations. So we had the TV modulator added to some, you had the floppy disk added into others. This one was actually rebranded the Atari Mega or the Atari Mega ST, depending on which model you got, and they put it into the sort of classic three-box design. So you had a separate keyboard, your base unit with your floppy drive in and the CPU. This monitor here is actually the high resolution monitor. It runs at 72 Hertz as opposed to 60 or 50 Hertz, which most computers at the time worked. And I would still say it's one of the crispest monitors I've ever worked with. Certainly only the Retina displays on the Mac come any close, or the 4K monitors come any close to the sort of crispness that you get on it. It was absolutely wonderful to work off. Of course, it sends the camera funny strobing at 72 Hertz. The floppy drive on this machine was borrowed for Alex's floppy disk orchestra. You can see that in one of the early computer file videos, which is linked here. So I've replaced this with a standard, well, it's actually from a Spark blade, from an Ultra Spark, so it actually still works. It's so I can use the machine. We then had the STE model, which we've seen, which added sort of better graphic support for things like hardware scrolling, better sound. It could do 8-bit DMA sampled sound as opposed to the sound chip that was in there. So it could do better sound. Still not up to the standards that you'd get with a MIDI keyboard, but it was better for games and things, although very few actually used it at all. We then produced two machines, one of which I haven't got here, it's at home, was the Atari TT, which had 680/30 processor, so it was much more powerful. It could run things like Unix and was designed for sort of the workstation market. But it was also compatible with the Atari stuff, but more the serious software compared to the sort of the games end of market. They also produced this version, which is a slightly faster version of the Atari Mega STE. Again, it's in the 3-box design, separate keyboard. This is actually a TT keyboard from Sweden, which you can still get as a spare part on eBay, even though Atari is long gone. I actually really like this design. You sort of refer to as the wedding cake design. It really is probably the nicest one they designed. The last computer then that Atari designed, again in the ST family, is this one, the Atari Falcon. It's a bit of a hodgepodge of a design, but it's got much better graphic support, much better sound in there. It's got 16-bit sound. It's also got what's called a DSP chip, which was probably put in there to do audio processing, but people have used it to do 3D texture mapping and all sorts of things. People have ported Doom to run on it, and there's someone even trying to get bits of Quake to render on there at a reasonable frame rate. That was the last machine Atari produced before they left the computer industry to develop the Jaguar games console. One thing that's perhaps surprising at that time, not so much now when laptops are common, but Atari did produce two portable versions of the ST. The first one, which was called the Stacy, really was a portable, luggable machine. It had a LCD display, but was basically a Mega STE with an LCD display bolted onto the back, and was huge, heavy, and needed mains power, but it was useful for musicians gigging out on stage. They could take it and plug it much easier than a full system. The second one, about 91, was a sort of hodgepodge of the Atari STE, which was called the ST Book. Much thinner, much lighter, long battery life and so on, really quite powerful, but hardly sold. I think less than 1,000 were actually made. However, one interesting thing is, as well as developing that, they also developed alongside it the ST Pad, which was a tablet, similar in the idea to something like the iPad, but this was back in 1991, so it had a stylus that you could interact with the operating system. It was never released and never to be, but it's interesting to think, could the tablet revolution have happened 20 years earlier?
And we put these chips in the BBC Micro and none of them worked. And we never knew why. Which of course means that we didn't know why the National Semiconductor one did work, right? And 1.5 million BBC Micros later, it was still working and I still didn't know why.